This is the second part in going over the exam review for the MCT4C course in detail. And so we're going to start here at the beginning of part number 2. And the very first question, there is a previous video on all the multiple choice questions for the first part of the exam. So in part 2 it says, first of all, to solve 81 equals 3 to the x minus 5. Now, because this 3 to the x minus 5 is written as a power of 3, the first thing you should do is write the 81 as a power of 3. So 3 to the what power gives you 81. Now, a couple ways you could find that. You could just trial and error and go, 3 to the power of 2 is 9, not big enough. So 3 to the power of 3 is 27, still not big enough. 3 to the power of 4 works out to 81. So 81 is 3 to the 4th. If that exponent is quite big, it might take you a while to do it by trial and error. So one thing you can do, if I wanted to write 81 as a power by 3, you can take the log of 81 and divide it by the log of 3. And that gives you 4. So that means that this 3 raised to this 4 would give you 81. So 3 to the 4th equals 3 to the x minus 5. Now, both of these powers have the same base, and the bases don't divide out. Because those powers are the same, equal, and the bases are both 3, we can then say, therefore, this exponent 4 must equal this exponent x minus 5, and then we can solve for x. So the 3's don't actually divide out, we just let the exponents be equal, and then we can find x. So to solve for x here, we would either add 5 to both sides, or take the 5 over and it turns to a plus 5. 4 and 5 add to 9. So 9 should be the solution or answer to this. The way you can check something like this, we go back to our calculator, and if I evaluate 3 to the power of, and in the power I'm going to put 9 in place of x, I'm going to do 9 minus 5 there. 9 minus 5, close the bracket, and that should work out to 81. And the fact that it works out to this number on this side means that that is the correct solution. So that's how you could check that. For number 2, we're asked to simplify each of this following, and a couple of instructions: leave answers with only positive exponents, no negative exponents, and no decimals. So the first one says we've got 2x to the 4th y cubed raised to the power of 5. Now that 5 means that each of these things, the 2, the x to the 4th, and the y cubed, all get raised to the power of 5. So we would do 2 to the 5th, x to the 4th to the 5th, and y cubed to the 5th. Now, once you get better at doing this, you don't really need to write out this step, but I'm writing out for explanation purposes. This is supposed to be detailed solutions, that's why I'm doing that. So 2 to the 5th is 32. That means, remember, it's not 2 times 5, it's 5 2's multiplied together. Now I could go 2 times 2 times 2 in the calculator if I wanted to, but I may as well just use the power key. And so 2 to the power of 5 is 32. Power over power, just like a question or two in the multiple choice, you multiply the exponents, so 4 times 5 is 20, and 3 times 5 is 15 on the y, so the final answer is 32, x the 20th, y the 15th. There's only positive exponents, there's no decimals, so we're done. For b here, we're evaluating 4a to the negative 3b to the 6 raised to the power of negative 2. So all of 3 of these things get raised to the power of negative 2. So 4 to the negative 2, the a to the negative 3 to the negative 2, and the b to the 6 to the negative 2. Now 4 to the negative 2, remember a negative exponent means the reciprocal. So that's equal to 1 over 4 squared. Notice the 2 in the denominator here. That exponent has now a positive exponent. Power for power again, so we multiply the exponents. Negative 3 times negative 2 is 6, and 6 times negative 2 would be negative 12. Now, I should evaluate this 4 squared, so 4 squared is 16, so basically the 4 to the negative 2 is equal to 1 over 16, and I have a negative power here, or negative exponent, sorry, so only positive exponents. So b to the negative 12 is the same as 1 over b to the power of positive 12. So basically, you're just bringing that down into the denominator, and the 12 becomes a positive exponent. In the numerator, all we have left is the a to the 6, because basically it's this 1 times a to the 6. If you think of the b to the negative 12, it actually is 1 over b to the 12, but again there's a 1 on top that you're multiplying by a to the 6, so it's still a to the 6. And the 16 is in the denominator, and then so is the b to the 12th. So now we have all positive exponents, no decimals, so we're done there. For the third one, we're asked to solve 6 to the power of x equals 90 using logarithms. And so basically what we're trying to do is find out what power do you raise 6 to give you 90. And so I'm going to show you two ways to do this. One way is to rewrite the logarithmic form in exponential form. And the exponential form, this is exponential form, to rewrite it in the equivalent log form. So the log says that the exponent x should equal the log of 90 base 6. The base of the power is the same as the base of the logarithm. And so we can evaluate this by, and you probably don't have a calculator that does base 6, but you can use the log key because it does base 10. So you take the log of 90 and divide it by the log of 6. And that looks like this. So the log of 90. So there's the 1.9542. And then of course we take the log of 6. And I wrote 4 decimal places here, so 0.778, and that would round to 2. And then we divide those to get 2.51. So that is our solution. Now, a second, slightly different way you could do this is you could just take the log of both sides instead of writing it in the log form. And so notice I wrote log of 6 to the x on the left and log of 90 on the right, trying to solve for x. So we use that power rule that if you have the log of a power, you can bring that exponent down in front and write as x times the log of 6. Now I'm trying to solve for x, so I want to get rid of this log 6. So I would take that same line and I would divide out the log of 6. So basically, what we would have here now, these log 6s would just divide out. And on the left, you just have x equals the log of 90 over the log of 6, which is the same as we have here. That's why these decimals are the same, and you get 2.51 again. Now, to check this, you could put 2.51 in place of x here and evaluate 6 to the power of 2.51, and you get this decimal. Now, it's not exactly 90. It's very close to 90. It's not 90 because we rounded a bit, okay? But it's close enough to 90 that you could probably convince most people that, yeah, that should be the right solution. Flipping over to question number 4 on the next page. A culture of bacteria grows according to the formula P of t, P stands for population after t hours, equals 200 times 2 to the power of t. Now, so it says in A, you're asked how many bacteria do the cultures begin with? Now, at the beginning, the time number would be 0, so we put 0 in place of time. So we evaluate 200 times 2 to the power of 0. Now, the 2 to the power of 0 is 1, and so 200 times 1 is just 200. So we started out with 200 bacteria. When you have a formula like this is usually the beginning amount, unless you alter the formula somehow. But if it's in that kind of format, then that number would generally be the starting amount. In B, you're asked how many bacteria are there after 10 hours, assuming that none die. So time is 10 hours. You put 10 in place of time here and here in the formula. Now be careful in this. If you remember order of operations, you have to evaluate powers or to the 10th before you go multiplying. So don't go 200 times 2 and raise it to the power of 10. The 200 is not evaluated to the power of 10. So we do 2 to the 10th is 1024, and it looks like this in your calculator. 2 raised to the power of 10 is 1024, and then we multiply that by the 200. And that's where this 204,800 comes from. So that's how many there are after 10 hours. Last question, number 4, says to the nearest tenth of an hour, how long does it take for the culture to grow to 2300? So the 2300 is the population, and we're solving for time in this case. In the first two, we were solving to find what the population is. Now we know the population, and we're solving for time. So 2300 goes here. Now I want to solve for time, so I would want to get the expression with the t in it alone. So I want to get the 2 to the t by itself. So I would divide out this 200, and that's what, see, this line is this line here, and then we divide out the 200. So those 200s would divide out. And so we're left with 2 to the t equals, and 2300 divided by 200 is 11.5. And so to solve for time, you could do the same thing we did in a previous question here, one of two ways. I rewrote it in the equivalent log form. So the exponent would equal the log of 11.5 and the base of the logarithm is 2. So basically it's the log of 11.5 divided by log of 2, which gives you 3.5. And you could just type that in your calculator like this. Log 11.5 divided by the log of 2, and you get 3.5 hours. So it takes about 3.5 hours for the population to reach 2,300 bacteria. For question number 5 here, you're asked which of the following relationship is a function or which ones aren't, and explain your reasoning. Now, what I've done in the first one here is I've drawn 3 different vertical lines because I'm using the vertical line test. And no matter where you draw them, here or here or here, it only cuts the curve in one spot. And so by the vertical line test, it would be a function. If the vertical line cuts in more than one place, like here, it would cut this spot, and also here, that would mean it's not a function because it fails the vertical line test. Now, question number 6, you're asked to state the domain and range of those 2 graphs in question number 5. So, let's go back to the 2 graphs. So the first one here, and this isn't the entire function. It does go forever down to the left and down, and the same to the right and down. It keeps on going as well. So it would exist completely as far as you want to go to the right and left. So that's why the domain would be the entire set of real numbers. So the domain is the set of real numbers. Now for the range, there's a highest point, a maximum point, and that point's 4. And so the highest y value is 4. All other y values are lower than 4. And so the way we would write that is the range is all real numbers with the restriction that y is less than or equal to 4. For the second one, the leftmost point on the graph is right here. So that's an x-coordinate of -1. And then if we scroll on the curve, the most right point is this where x is 2. So x ranges between -1 and +2. So we write that as it's all real numbers for the domain, such that x is greater than or equal to -1 and less than or equal to 2. Now the highest y value is here, which is 3, and the lowest is here at -3. So the range would be the set of y values between -3 and 3. For question number 7, all 3 parts here, we're going to use this graph. It's supposed to show the path of a ball that was thrown. In an A, you're asked, what's the maximum height of the ball? Well, the maximum height is here. And you see, that's 45. So it's a little bit over 45, so it looks like about a couple above 45, so the maximum height is about 47 meters. And B asks, when did it occur? So we scroll down along the graph here, and at 3 seconds, that's when it occurred. For C, it says, from what vertical height was the ball thrown? So that means what's the initial height at the beginning, like at 0 time. So you would look for the y-intercept right here, and it's about 2. So it was thrown from a height of about 2 meters. At time 0, the height was about 2 meters off the ground. Scrolling over to the next page, question number 8. We're given this function here and told that it gives the height of a football that travels through the air after being thrown, where h is the height and d is the horizontal distance it's gone, the distance like straight out along the ground from whoever threw it. And they're both measured in meters. And in A here, you're asked at what horizontal distance does the ball reach its maximum? And there's 2 main ways to find that. The solution number 1, this actually comes from the quadratic formula. Maximum points or minimum points occur at, and remember A, B, and C are the numbers for the quadratic formula from the equation here. So A would be -0.01, B would be 0.36, and C would be the 1.6. So if we use negative B over 2A, that actually gives you the, well, it's the D coordinate, or we often use X to represent it, of where the maximum or minimum occurs. The quadratic term has a negative coefficient, so the projectile looks like this, so we know it has a maximum point. So if we put 0.36 here in place of B, we'd have negative 0.36 on top, and 2 times A, which is 2 times this in the denominator. And so that calculation would look like this. We will go negative 0.36, and divide that by 2 times the negative 0.01. And that works out to 18. So a horizontal distance of 18 is where the maximum occurs. Now another way to do this is the procedure called completing the square. We're going to put that in its vertex form, and the completing the square, the vertex form actually tells you both the maximum height or minimum value and also where it occurred too. So it's actually going to answer questions A and B here, because BS, the BS for what the height is. A is just at where it occurs. Now, the completing the square method, the steps look like this. I'm going to bring my calculator back over here. The first thing you do is whatever the quadratic coefficient here, the negative 0.01, that gets factored to the two terms that have, well, are d squared and d, or x squared and x, whatever your variable is. You do not have to factor it out of the 1.6, the number in the end. In fact, it's a good idea not to, because that actually complicates things. So if we factor a negative 0.01 out of a negative 0.01 d squared, then we would have a d squared at the beginning. To factor it out of the 0.36d, you actually divide the 0.36 by that decimal, negative 0.01. And that gives you negative 36, so that's why this is a negative 36d here. So the next thing to do is to add and subtract a number to make this a perfect square trinomial. And the way you find that number is you take the negative 36 and you always divide it by 2. The reason it's 2 is because when you have a perfect square, there's 2 factors. If there happened to be 3, then we'd be dividing by 3, but there's only 2. So you get negative 18, and then you square that negative 18. So we would evaluate negative 18 squared, which gives you 324. So we add 324. Now we need the 324 to make it a perfect square. We have to subtract 324 to keep the equation to have the same value. So you only actually need the 324 for the perfect square part, but you need negative 324 so the equation has the same total value. Now that negative 324 has to come out because we only need the 324, the positive, for the perfect square part. So when it comes out, it gets multiplied by this negative 0.01. So if we enter that in the calculator, that gives you 3.24. So that's why this becomes 3.24 outside the brackets. Now the next thing to do is to factor this. D squared minus 36d plus 324. It should be a perfect square. Both terms are the same. Has to start with a d because it's d that you square to get d squared. Now actually I'll tell you 3 different ways you can find out that it's negative 18 here. Number 1, negative 18 is the number that we got when we divided negative 36 by 2 and then squared. So that's one way that it's negative 18. Another way is that number right there has to always be half of this coefficient. So half of negative 36 is negative 18. Another way to find it is this number is what you square to get 324. 18 squared is 324, and the sign has to be the same as the sign of this here. So there's a couple different ways you can get how that factors. If we add 3.24 and 1.6, you get 4.84. So the vertex would be at 18, 4.84. The first coordinate is the d, the horizontal distance. So that's why that's how you get the d is 18, just like d is 18 here. And the 4.84 is the height, the h coordinate or y coordinate if you want to put y there. So that's how high it is. That's the maximum height. That's the answer to B here. Now, if you didn't do this method, you could still answer B, because once you get the 18, all you have to do is put the 18 in place of D to find out how high it is when it's 18 meters downfield. So we put 18 in place of D here and also here as well and evaluate that, and lo and behold, you get 4.84 meters again. So that's another way you could do question B here. For question number C, you're asked at what horizontal distance does the ball land? Now, when it lands, if we go back up to the original equation, when it lands, the height should be 0. So that's why we put 0 in place of h. So 0 is here in the formula. And I'm just going to use the quadratic formula here to solve this. So A is negative 0.01, B is the 0.36, and C would be the 1.6. So if we substitute all those numbers in the quadratic formula and evaluate, and one thing to note here, remember, inside the formula, when you multiply negative 4 by negative 0.01 times the 1.6, a negative times negative is a positive. So this will actually be a positive number, you'll be adding to whatever 0.36 squared is. So be careful of your signs there. Now you get two different d values, negative 4 and 40. Now it's practical application. The horizontal distance couldn't be negative. That would mean that it land behind where you threw it, so it doesn't make any sense. So the 40 downfield is what does. There should be two roots to this equation. If you're going to graph it, the negative 4 would be the root over here. This part really isn't important at all for the question because it's kind of thrown from here, follows this path, and then lands over here. But to graph it, that negative 4 is useful. So negative 4 is a root, the 40 is a root where the height is 0. Remember, the maximum occurs at 18. So if we go over to 18 and up to almost 5, remember it's 4.84, that's the maximum. And then we can draw the graph here. In the original equation, the constant in the end, the 1.6, is the y-intercept or height-intercept. So that's why it goes through here a little under 2. That's the height from which it was thrown. And on to the next page, question number 9. This will be the last one we'll do in this segment, and I'll finish the rest of the exam review in the 10 and afterwards in the next and last video. In A here, we're asked to sketch the graph of f of x is equal to x minus 2 times x plus 6. So it's in a factored form. If we set each of these to 0, we can find out what the x-intercepts are. And so setting x minus 2 to 0, bring the 2 over, and you get x equals 2. So 2 is a root, or x-intercept. If we set x plus 6 to 0 and bring the 6 over, we get negative 6. So negative 6 is another root, or x-intercept to the graph. So that's that point and the 2 here. Now, one other very useful point to graph this would be a quadratic relation, a parabola, because there's two factors. So it's going to be x squared if we multiply it out, is to find the axis of symmetry and then where the vertex is. So if you average these two numbers, the negative 6 and the 2, or find the middle between them, that's the same as averaging. So if I take my 2 and negative 6 and add that, that's negative 4, divided by 2 is negative 2. So x equals negative 2, which would be this line right here. That's the axis of symmetry that has to go through the vertex. And so that tells us that the x-coordinate of the vertex is at negative 2. So we can find what the y-coordinate is, we're looking for this number now here, by putting that negative 2 back into the function in place of x here, here, and here. And so that's what that looks like. This would be negative 4 times positive 4, which is negative 16. So negative 2, negative 16 is the vertex. So the vertex is right here, negative 2, negative 16, and then we could draw our smooth parabolic curve between all that. Moving on to question B. Okay, g of x equals x plus 3 times x plus 1 times x minus 4. If we set each of these to 0, just like we did the two factors above, we will get negative 3, negative 1, and positive 4. Remember, the signs just change when you move those numbers over to the other side of where the equal sign is. So negative 3, negative 1, and negative 3, negative 1, and positive 4 would be where these three roots are. So there's three places. This is a cubic function because there's three x's here. X times x times x is x cubed. They're all positive, so it'll be a positive x cubed. That's how I know it's a positive cubic function, and it should have this sort of general shape. Now, I found a few more points to graph it more accurately, and you might not on the exam be trying to find 4 or 5 different points, but this is a way you could graph it a little more accurately. So what I did was I basically took a point to the left of this root, and then in between them, and another point or two in between as well, just to get a few points to graph more accurately. So if you remember, this was at negative 3, so I used negative 4 as my first point. So I'm really just putting negative 4 back into the function in place of x here, here, and here. And so there's the negative 4 substitute in. So that's negative 1, that would be negative 3, and this would be negative 8. We're multiplying to give you negative 24. So negative 4, negative 24 is a point in the graph. So left 4 and then down 24, there's a point in the graph. I also found if x is negative 2, kind of did these two out of order, I suppose, but if we put negative 2 in, you get 6. So negative 2, 6 is a point in the graph. And then I put 0 in as well. So if I put 0 here, here, and here, you get negative 12, which is actually the y-intercept. And then I did 2 also. So I kind of wanted to, because this is a bit of a stretch between these two, so you know what's going on between here. So I did 2 as well. I put 2 in place of x and got negative 30. So 2 negative 30s on the graph, and then you can draw your graph a little more accurately. Okay, last part here in C, and I have another grid down here for this one. So x cubed minus 4x, or h of x equals x cubed minus 4x is what we're graphing. And you can, it's not in the factored form like the first two. So there's you can common factor an x out, because they all have x's. There's no number in the end here. So if we divide an x out of an x cubed, we get x squared. Negative 4x divided by x is minus 4. And this is actually the difference of two squares. X squared is a perfect square, and so is 4 because it's 2 squared. So that'll factor into x minus 2 and x plus 2. Now if we set this x equal to 0, we get 0. So there's one root right there at 0. If we set x minus 2 equal to 0, we get 2 for a root. And so that would be this 2 right here. And then the x plus 2, if we set that to 0, we get negative 2. So there's negative 2 as well. So there's the 3 roots right there. And then it should be a positive cubic function because it's x cubed, 1x cubed. Okay, so positive coefficient and x cubed, so it's cubic. And then I found a few more points to graph it more accurately. So this was at negative 2, so I used an x value of negative 3. And I put negative 3 in place of x here and there as well. And that's negative 27, this would be plus 12, so negative 15. So negative 3, negative 15 is a point on the graph. And I also did negative 1. Negative 1 in place of x, I get 3. So negative 1, 3, which would be this point. Notice vertically, each block is 2. I have some fairly high, large y values. That's why it's not 1. So it's just 2, 4, 6, 8, and that would be 10. And then I also found by putting 1 in, 1, negative 3 is a point in the graph. So 1, negative 3, and then 3, 15. That's this calculation here. So over 3, up 15, and then I can draw my cubic shape through those points. And that's what it looks like.